Hi everyone, I am Reddy Kottam. I am working as a software engineer in Aja Consulting Services LLP. So today we are going to solve a problem on lead code using data structures and algorithms. So think of data structures and algorithms as the engineering behind software performance. They decide how fast, how efficiently and how scalable your application is. So why data structures and algorithms? Uh, Without DSA, you may solve a problem, but poorly. Example, searching a number in a list. Uh, the brute force approach is we can get it by big O of n square in time complexity. But we need to achieve the optimized solution using big O of log n time complexity. So performance matters a scale. When your system handles thousands of users, okay. When your system handles millions of users, DSA becomes critical. So this is the main problem when our system traffic increases. So we need to optimize the solution. So in this matter, we need to use data structures and algorithms very effectively, and using those in the right place and with using right algorithms and data structures, we can achieve better problem solving. The third one is better use of memory. Efficient data structures helps reduce memory usage, manage large data sets using hash map instead of list for lookups, faster plus optimized. Every system you build uses DSA internally. Databases, APIs, payment systems like Razorpay, work you are doing. Let's take a real life example. Suppose if you are searching for a product on Flipkart or Amazon, suppose the same product in both the applications, if you are searching on the Flipkart, the time which is taking to render the project takes lot of time. So user uh, change may switch to the different application like Amazon. So if we doesn't satisfy the user, then he might switch to the different application. So getting that product details faster, uh, we might use data structures and algorithms. Sorting products by pricing, rating, filtering results instantly. So sorting and searching algorithms are effectively used in Amazon and Flipkart, and we can say in movie booking system like uh, uh, Book My Show. So arrays and matrices, concurrency plus greedy, looking logic. So in payment systems like Razorpay, queues handles transactions, request in order, hashing, fast lookup of users' payments, so etc. So these are some real life examples of using data structures and algorithms. So let's look into a problem in lead code. So today we are going to look at the most frequently asked DSA question, valid anagram. So the most basic and the important thing in DSA while solving a problem is understanding the problem statement. So we need to read twice or thrice to understand the problem. And first, we need not to jump directly into the optimal solution. First, we need to think about the brute force solution, and then we need to jump into the optimized solution. That's where we can build our logical thinking. So here you are given two strings, string S and string T. Your task is to return true if it is an anagram, false if it is not. So as we can see here, anagram. So this is one string anagram and T is one string anagram. So these two strings are anagram because with the letters present in the anagram we are making into the another meaningful word, nagaram. So here we can see another string s, it is rat, and here the t string says it is car. So these two are not matching. We can't make a meaningful word using these letters in the s. So it is false. I hope you got an understanding on what needs to be solved. So now let's look into the solution. Here we have class declaration, uh, and we have a method is anagram, which accepts two strings, string s and string t. First of all, we need to check the base condition, whether suppose if the letters in string s are greater than the letters in the string t, like if the length of the string s is greater than or less than the length of the string t, we cannot make a word, because we cannot make a meaningful word when both the strings are not matching in the length. So we can directly return the false. After that, we are taking a string builder to build a new string. So string builder is used because strings in Java are immutable. So here we are looping through each character of S, converts string S into a character array, iterates one character at a time. Here we are converting character C to a string and find the first occurrence of C in temp. If the index is greater than or equal to 0, we found the character. If the index is equals to the -1, we did not found the character and we are directly returning the false. That means T does not have the same characters as S. So it's not an anagram. Finally, after iterating to all the characters in the S, we need to check here if the false is not returned, then we can say that it will return the true, and we can say that this string S has matched the string T with all the characters in it. So let's run this program. Here the test results are passed, and now we'll submit the. As we can see, the solution is accepted, and it took 64 ms time, and it is beating around 5.38% solutions, and the memory we used is 46.74 MB. So now now let's think about the optimizing the solution. So here what we have done is we have iterated through each the character in the string. So we are iterating big of n times, and also we are using a string builder here. So we have used extra space in this solution. So now we need to make this solution optimal. So now let's talk about the optimal solution. As in the brute force approach, If both the length of strings does not match, we need to return false because we cannot make a anagram. Now we are taking an int array of size 26. So here we are taking 26 length of array and it is constant. So we are not using any extra space. The space complexity will come up to big of 1 even if it because we are taking 26 length of an array. So now let's iterate through through the string s. We are counting the each So in this for loop, let's go through what does it do. So take character from s, increment the count, take character from t and decrement the count. So example, if we have seen in s we have anagram, so we are counting the each characters and from the so now let's go through the solution. Here we are counting each character from the string s and also we are decrementing the each character from the string t. So at the end of the solution, if any character's count is greater than 0 in the int array, so it is not an anagram because it should satisfy all the characters in the string s and string t. If it is if the all the characters length is 0 in the count is 0 in the int array, then we need to return true because if all the characters count is 0 then it is an anagram because we have incremented here for string s and also decremented here, so it is equally matching. So if both the count is 0 then we need to return the true. So now let's run the program. So we can see both the test cases are passed and let's submit the program. As we can see, it see 5 ms of time. It is more or less than the first brute force approach and it took also 44 MB. So it beats 91% of all the solutions. As we can see the time complexity and space complexity, because it is iterating through each and every a character in the string. Let's say if the length of the string is n, then the time complexity would be big of n because it iterated to each of the character in the string. And here if we see we are using 26 length int array. So as 26 is constant, we are not using any length n space, so we can say that it is using big of 1 complexity. Thanks everyone.